Hello viewers, welcome to this video. I've done videos on how to set up a Kubernetes cluster using Kubeadm manually. I've got documentation on my Github repository on how to use Kubeadm to provision a Kubernetes cluster on CentOS 7 or on Ubuntu 20.04. I've also got my Vagrant environment that uses Kubeadm to provision a Kubernetes cluster. A few of you asked me how we can use Kubeadm to set up a highly available Kubernetes cluster with multiple master nodes. So that's what this video is about. So in this video, we're going to be using Kubeadm tool to set up a Kubernetes cluster with multiple masters. All right. So let me go to my Github repository. And in my Kubernetes repository, I've just added some code here. So Kubeadm HA multi-master. So what I've got is just a Vagrant file. I'm going to start with some virtual machines. So if you've got physical servers, if you've got other forms of virtual machines, this documentation, this process should work equally. But to make things a little easier, I've got a Vagrant file. So once you do a Vagrant up, so what you will end up is you will have 4 virtual machines, a load balancer, couple of master nodes and 1 worker node. So the assumption is if you're using my Vagrant environment using this Vagrant file, you will have these set of machines. So load balancer will have 1 gig of RAM and 1 CPU. The master nodes will need to have 2 gig of RAM and 2 CPUs and another worker node with 1 gig and 1 CPU. So all of these are going to be Ubuntu 20.04 virtual machines, and I've assigned in my Vagrant file, I've set a private network for all these virtual machines in this IP range. We're going to follow this documentation here and let's set up a highly available multi-master Kubernetes cluster. So before we go, if you want to try this on your workstation, make sure you've got at least 8 cores because we might be needing 4 gig of RAM for the master nodes and 2 gig of RAM each for the worker node and the load balancer, and we will be assigning 6 CPUs for all these 4 virtual machines. So make sure you've got at least 8 cores and 8 gig of memory, and the other requirements are just have VirtualBox installed and Vagrant installed. So I'm going to clone this repository now. Git clone Kubernetes. I'll put a link to my GitHub repository in the video description if you want to check out. So once we've checked out Kubernetes GitHub repository, and if I cd into Kubeadm HA multi-master, and we have our Vagrant file, and I've got a bootstrap file. Okay, let me show you what we've got in the Vagrant file. Okay, so Vagrant file, we've got a code block that provisions a load balancer node. I'm using Ben2 Ubuntu 20.04 as the base image, and I've assigned it a private network of 172.16.1600 and a couple of master nodes. Master node count is 2, and it goes in a loop and creates 2 virtual machines for kmaster1 and kmaster2, and it will get the IP address in the range 101 and 102, and node count is 1. So we will be provisioning 1 worker node, and it will be kworker1. So if you want to play with it, if you want to increase the number of master nodes and the number of worker nodes, just change this variable as per your liking. So that's what we are going to start with. And in here, and I've got the bootstrap script, which is simply, it's going to set up the root password. So for any of you following my Vagrant environment, you must be knowing that I'll be using Kubeadm as the password for the root account. So that's what this bootstrap does. And apart from that, it also enables root SSH login and also enables password authentication. So those are the only 2 things that I'm doing with the bootstrap script. Otherwise, you will end up just with plain blank Ubuntu 20.04 virtual machines, 4 of them, 1 for load balancer, 2 for master nodes, and 1 for worker nodes. So that's our starting point, right? So I'm going to do Vagrant up, and it's going to take a few minutes for the virtual machines to come up. So I'm going to pause the video meanwhile, and I'll come back when the machines have been provisioned. Alright, so we have all our virtual machines provisioned. So I'm going to go back to the documentation. We've done the Vagrant out. The first thing we're going to do is we're going to set up the load balancer node. We are going to be using HA proxy as the load balancer to load balance between the multiple master nodes. Okay, so all your interactions with your Kubernetes cluster has to go through this load balancer node, which is running HA proxy. Alright, so I'm going to log into the load balancer node. So SSH root at the load balancer node's IP address is 172.16.1600. which is here 172.16.1600, and let's log in, and the password is Kubeadm. Okay, so we are inside the load balancer node. The first thing is we update the apt repository apt cache and then install hproxy. Alright, so hproxy is installed. So now I'm going to edit etc hproxy hproxy.cfg, and I'm going to add this piece of code here. So I'm going to copy that and edit etc hproxy hproxy.cfg, go all the way to the bottom and then paste it here. So what we're doing here is we're defining two code blocks. One is the front end and the other one is the back end. So the front end is binding to the IP address 172.16.1600, which is the IP address of this load balancer node, and I'm listening on port 6443. And the default backend is this backend block here. The backend is served by these two servers, kmaster1 and kmaster2, and their IP addresses are 172.16.16.101 and 102, and we are just passing all the traffic to 6443 port in a round robin fashion. So if you look here, the important thing is mode is TCP, because we don't want to terminate SSL at the load balancer. So you don't have to worry about creating your SSL certificates and so on in the load balancer node. So all the SSL termination will happen at master nodes, the Kubernetes master nodes, kmaster1 and kmaster2. So it's important to specify mode as TCP, which is SSL pass-through. All the traffic that's hitting this IP address and port will get directed to one of these master nodes in a round robin fashion. Okay, so save that and then restart the hproxy service. Okay, that's done. And if I do systemctl status hproxy, okay, so hproxy is running, and you can see here kmaster1 is down, kmaster2 is down, so that's fine, don't worry about it. We haven't set up the cluster yet, so that's fine. Just make sure that the hproxy service is running fine. Alright, so we are done with the load balancer node. That's it, we don't have to worry anything about it for now. Okay, so next, on all the Kubernetes nodes, there are certain common steps that we need to be running on all the Kubernetes nodes, the master node and as well as the worker node. So things like disabling firewall, turning off the swap, and ensuring there are a couple of kernel parameters set, installing Docker, adding the Kubernetes apt repository, and installing the Kubernetes components. So all these steps needs to be done on all the Kubernetes nodes, master nodes and worker nodes. So I'm going to log into all the three Kubernetes nodes, the two master nodes and the worker node. I'm going to be running all these commands now. Okay, and there are certain commands that needs to be run specifically on the master, and there are some commands that needs to be run only on the worker node, which we will come to in a minute. So first, let me log into all the nodes. So I'm going to open up three panes, and on the top pane I'm going to log into 101, which is kmaster1, and the password is kubeadmin. And on the bottom left I'm going to log into 102, which is the second master node, kmaster2, same password, kubeadmin. And on the bottom right I'm going to log into 201, which is kworker1, the worker node, and kubeadmin, the same password. And I'm going to synchronize my pane for ease of use. Okay, so I've synchronized my pane. So if I just type in command on one pane, it gets replicated, synced on all the panes. If I do cat etc os release, you can see I'm running version 20.04 Ubuntu on all these machines. Let's disable let's disable firewall. UFW disable. Okay, that's done. Let's disable swap permanently in the etcfs tab as well. And then we need to make sure that we have these two kernel parameters set, and also make it effective for this current session. Okay, copy that, paste it, clear the screen. That's done. And now we're going to install Docker Engine. Okay, copy that, paste. It's going to take a minute or so, so I'm going to pause the video again. Alright, so Docker is installed, and if I do systemctl status docker, you can see Docker is running fine. Let me clear the screen, and the next step is to add the Kubernetes apt repository. Copy that, paste it. Okay, that's done. And finally, we're going to install the Kubernetes components, Kubeadm, kubelet, and the kubectl. So the version that I'm installing is 1.19.2, which I believe is the latest, I guess. Okay, let's start that, and it's going to take a couple of minutes. Again, I'm going to pause the video and come back when all the components have been installed. Alright, so we are done with installing all the Kubernetes components. I think we are done with all the common steps that are required on all the worker nodes, all the Kubernetes nodes. So now what I'm going to do is I need to initialize the Kubernetes cluster. So using this command, I'm going to initialize the Kubernetes cluster. But this needs to be run just on one master machine, either kmaster1 or kmaster2. So I'm going to pick up kmaster1 and I'm going to close all the other terminals, turn off synchronization, and I'm going to exit out of all these. Okay, alright, so I'm on kmaster1 and I'm going to run this command here. Kubeadm init -- control plane endpoint. This is the control plane endpoint. So all the interaction will be coming in through the load balancer. And if you look at the IP address here, it's the IP address of our load balancer where we set up the HA proxy. So HA proxy is listening on port 6443 on our load balancer virtual machine 172.16.1600. So that's the control plane endpoint. So that's the new option to the Kubeadm init command. And also you need to pass the upload certs option. And don't forget to specify this one. This is very important. API server advertise address is 172.16.16.101. This is actually required. So if you've got a physical server with just one active interface, you don't have to bother using this option here, -- API server advertise address. But if you're like me using VirtualBox, and if I do, I'm on kmaster1, it's the same case for all the virtual machines. If I do look at the interfaces, you can see here there's this interface. This is the first interface and it has the IP address of 10.0.2.15. So all the VirtualBox virtual machines will have this IP address 10.0.2.15, right? So when you do Vagrant up, Vagrant uses this interface to get into it, but it's not a public interface. So all the outbound traffic has to go through this interface 172.16.16.101. So if you're like me using VirtualBox and if there are more interfaces, you need to specify -- API server advertise address and point it to the IP address of the active network interface that has internet access. So otherwise you can just leave it. Okay, so I'm going to run the initialization command and the pod network CIDR is 192.168.0.0/16. So I'm specifying the pod CIDR network to be in this particular range because later I'm going to be using Calico as the overlay network, so which requires by default the network CIDR to be in this range. If you want to change this pod network CIDR to something else, you also need to tweak the Calico before deploying Calico, and you need to make some adjustments. But by default, Calico uses this subnet range. So make sure to specify pod network CIDR. So all the pods in your Kubernetes cluster will get IP address in this range, which Calico uses. Okay, so I'm gonna run this command and it's gonna take like 3 to 4 minutes to download all the images and start all the services. And I'm going to pause the video recording here and then come back when it has been completed. Alright, so the cluster initialization has completed. Well, it took less than a couple of minutes, but depending on your internet speed, it has to download lots of images. Okay, so that's done, and let me open up another pane here. Okay, so at the end of the output, you can see a couple of Kubeadm join commands. So this command, one command here, and there's also another Kubeadm join command here. So the command that you need to be using to join additional master nodes to this cluster is this one here. And you can see the option -- control plane. You can join any number of control plane node which are master nodes to this cluster by running this command. And if you want to join a worker node, use this command instead. Okay, so on the bottom pane, and I'm gonna log into 102, which is the other master machine, kmaster2. Kubeadmin is the password. Okay, so in here I'm just going to run this command, but there is one thing that I need to do. If you look in my documentation, we'll come to deploying Calico later, because if I do Calico, all the output will be lost. So I need to copy these two commands here. So I'm just gonna initialize the other master node and worker node before deploying the Calico network. Okay, so we need to be running this command to deploy Calico network, but I'll come to that in a minute. So now we are in this step, joining other nodes. So we're going to join kmaster2 to this cluster that we just initialized, and we're also going to join kworker1. Other important thing when you're joining the master node, the additional master nodes, is you also need to specify the API advertise server. API server advertise, is it? API server advertise address. Yeah, just copy that And the API server advertised address for this master node kmaster2 is the IP address that you want to use for API server traffic, which is 172.16.16.102. So .102 is the IP address of this kmaster2, and you need to specify this. You don't have to specify this for the worker node. You can just run this command on the worker node to join the node to the cluster, but for master nodes you need to specify this if you're running in VirtualBox, all right, with more than one network interface. Okay, so I'm going to run this command, and it's again going to take a minute or two. I'm going to pause the video and come back when it's done. Alright, so that's done, and I'm going to exit out of this, and I'm going to log into 201, which is our worker node, kworker1. Kubeadm is the password, and I'm going to run this command here, Kubeadm join. And if you look at the IP address here, join, we are going through the load balancer node 172.16.16.100. Okay, so if I do that, so now it's joining the worker node to this cluster that we've got. So this is not going to take a long, unlike master node, which takes like a minute or two. This one is instant, and it has joined the cluster. So I'm going to exit out of it. Okay, so now we are back in kmaster1, and now I'm going to deploy the Calico network. So in here, I'm just going to run this command here. So if I just do kubectl --kube config, so I'm logged in as the root account, root user, and the Kubernetes configuration file by default is the etc kubernetes admin.conf, and any kubectl commands that you want to run on these nodes, you can just use this syntax here, kubectl, and specify where your kube configuration is. Later we'll be downloading this kube config file to our host machine, and then we can run kubectl from our host machine. But first let's deploy the Calico network. So if I do get nodes, and you can see here we've got two master node, kmaster1 and kmaster2, but all of them are in a not ready status because it needs the core DNS and the Calico overlay network. So once we deploy that, all the nodes will be healthy and it will be ready to accept workloads. Okay, so let me copy that, and we are deploying the Calico network. Okay, it's deploying lots of custom resource definitions. Alright, so I'm exiting out of it. I'm on my host machine. Now I'm going to copy the Kubernetes configuration file from one of the master node to my host machine so that I can run kubectl commands directly from my host machine and interacting with the Kubernetes cluster that I deployed using the VirtualBox virtual machines. Okay, so the thing to do is make a directory .kube under your home directory, and then you're gonna use scp to copy etc kubernetes admin.conf file from any of the master node. It doesn't have to be 101, which is kmaster1. You can also download, you can also run the same command using 102 IP address, which is kmaster2. You just need to grab this etc kubernetes admin.conf file and then put it under .kube in your home directory as config. Okay, and it's going to ask for the password, which is kubeadm, and we've got the admin.conf file. Okay, so now if I take a look at the config file we just downloaded, you can see the Kube API server's address is 172.16.16.100, which is the IP address of the load balancer. So all our kubectl interactions will be going through the load balancer in a round robin fashion, and it will go to the backend master node. So we've got two master nodes. So now I can run things like kubectl cluster info. Okay, so that's our Kubernetes master, which is on 172.16.16.100, which is again the load balancer's IP address. I can do kubectl get nodes, and you can see here all the nodes are healthy and it's in the ready status. So now we've got a perfectly highly available multi-master Kubernetes cluster using Kubeadm. So this is how you use Kubeadm to deploy a multi-master node. So you can add additional masters if you want. I've just shown you how to add two master nodes, but always when you're setting up a cluster, make sure to add at least 3 master nodes. All right, 3, 5, 7, and so on. So if you want to add an additional master node, it's just simple. You just have to run that command, the kubeadm join command. Just create another virtual machine and go through all these steps like disabling firewall, swap, kernel parameters, install Docker, add the Kubernetes repository, and install the Kubernetes components. You don't have to initialize your cluster. You've already initialized your cluster. All you have to do is just make sure to copy that command that you got at the end of Kubeadm init command. So that those two commands, one for adding additional master nodes and one for adding additional worker nodes, and then you are good to go. And if I do kubectl -n kube system get all, everything is running fine. We've got the Calico node on all the 3 nodes. We've got core DNS, HCD, API server controller, scheduler, kubeproxy, all running fine. And I can do kubectl create deploy nginx --image nginx just to verify that things are working fine. Kubectl get all container is getting created. Kubectl get all. Okay, our container is running. Let's delete that. Kubectl delete deploy nginx, if I spell it correctly. Okay, so I think that's all I wanted to show you. I've been doing videos on how to set up a cluster in CentOS 7 Ubuntu 20.04. This demo is specifically for Ubuntu 20.04, and if you want, you can add practice adding additional master nodes and worker nodes. If you've got any questions, let me know. I'll be happy to help. Make sure to subscribe to my channel, and I will see you all in my next video. Bye bye.